Our objects are easy enough to create, but they're still a bit rough around the edges. So for instance, if you create a square and you assign it to a variable, sq3, square 3, and then you try to print its area, but you forget to set aside for it, as you would have seen, you get an error. So this says attribute error. What is an attribute? An attribute is a variable that belongs to an object, say the side of the square. It's also called an instance variable, just as when we refer to a function such as area that's actually part of the class or of the object, we call that a method rather than a function. This is just object-oriented speak. But apart from terminology, how are we going to make sure that this type of errors don't happen? And luckily, Python provides us with a mechanism that's called a constructor. And a constructor is a special method that is called each time you create a new instance, and that can be used to initialize all the variables that that instance needs to be defined, so all the attributes of that instance. So let's see how it works. The constructor is a method, as we said. The name is always init, and it's underscore init underscore. This underscore in Python often indicates that the particular name is kind of part of the internal workings of the data structure, the object, whatever you are talking of. So if you type, for instance, dear list or dear string, you might find that among the methods listed, there are a few of these funny methods with a double underscore, and those are kind of part of the internal machinery. So concretely, how do we add a constructor to our square class? We just define it as any other method. So that's the name, and it's standard. It does take the self parameter, and it takes whatever other parameters we want. And in this case, we put in an s. This is just any variable, any parameter, and the action of the constructor in our case is to take s and assign it to the side of the square. Now, how are we going to call that constructor? And that's where it gets interesting. We call it this way. We write sq1 equals square and the brackets, and we put the parameter of the constructor inside those brackets. So actually, you may have found this syntax slightly funny in the examples above, because we said, okay, right, in order to create a square, you've got to put brackets after the name of the class, but the name of a class is not the name of a method, so why do we need to call it as if it were a function? Well, it turns out that that one is the function that is actually called, and if you don't specify one yourself, so if you don't write this init, there is a standard one that doesn't do anything, but if you do write one, then any parameter that you put here is going to get passed to your constructor. So this is a much neater way of assigning to the side of the square, and especially we're now obliged to do that. So if you try to initialize the infamous square 3 without putting a side parameter here, you will see that we get an error. It says the constructor init is missing one required positional argument. So now we can't do that any longer. We are guaranteed that each time that we create a square, we initialize the side so that the code for the square is going to work properly afterwards. As a last note, I want to actually reinforce this, that you see, s and self.side are two different things. So s is just a parameter of the function init, and like any other function, the constructor can have parameters. Like any other function, a method can have its own internal variables. So for instance here, when I'm computing the area, I could be doing something like that. Result equals self.side times self.side, and then return result. this doesn't change the behavior. The area is still the same. But now you see this method has got a variable that's internal to the method. It's just like any other variable internal to a function. And this s behaves just like any other parameter that you pass to a function. In particular, these two things vanish once the function returns, and they're lost, right? You can't access this result variable outside the area method. But on the contrary, variables that start with self dot, like self.side, in this case it's the only one, belong to the object. And therefore, you see, they get stored in the object and they remain, they are part of its internal state. If you look at what happens when you call square with the parameter 2, well, what happens is that s becomes 2, and then this 2 gets stored in self.side, and then the constructor returns, and after a while you are calling square1.area, and square1.area can still access self.side. And if you are calling square2 perimeter, this will also access self.side, but the self.side that it accesses is the one of square2, so self would have changed, and therefore this call will access the value of the side that's appropriate for square2 and not for square1. This may sound a bit complicated when you first hear of it, but in reality, as soon as you start using these things, it makes a lot of sense. It's quite natural. It's the behavior you would expect from them.